Hello, everyone, and welcome to another episode of 2D Twin Stick Top Down Shooter. My name is Kasanas. Guys, in the last episode, we took a look at aiming and moving our character. And one of the problems with aiming moving our character is that right now we don't have a camera that actually follows our character. So we're going to fix that right now. All right, let's get started. All right, guys. So having our camera follow our player is not a difficult task. If we wanted to do it really quick and dirty, we could actually just simply grab our main camera and we could make it a child of the player base. Therefore, every time the player base moved, the camera itself would move as well. This would ultimately kind of give us jerky motion. It would feel really stiff and not very nice. We want to apply the concepts of the 12 principles of animation, not only to our character animation and our environmental animation, that kind of stuff. We want to apply the 12 principles of animation to our camera as well. One of the 12 principles of animation is a slow in and a slow out. Slow in means that an object will not instantly stop, and it'll slow down over time, coming to a rest eventually. Slow out means it doesn't instantly start at its maximum speed. It slowly reaches its maximum speed and then it maintains that maximum speed. And I know right now you're thinking like, whoa, I'm not using slow in, slow out for my character. In fact, for my movement, I'm using velocity. I'm instantly setting my velocity to a particular value. And yes, so there are many cases of the 12 principles of animation that we have to know which ones we want to use and which ones we don't, and when we want to use them and when we don't. Slow in and slow out is one of those principles. We don't always want to use it. However, in the case of our camera, having a slow in and slow out associated with the camera is going to make your animation of the camera look a lot better. So how do we go about adding in this slow in, slow out? There's a bunch of different ways to do it, but we're going to do it through code. And what I've decided to do, my last video went a little bit long. I want to try and reduce the length of these videos. So what I'm going to do, instead of me typing the code over and over again and having you guys watch me type it and make spelling errors and make fun of the names I'm using and everything else, I'm just going to create the code and afterwards I'm going to demonstrate the code for you. So I've made the code in advance. I'm now going to go through line by line and talk about what the code does. Okay, to follow along, here's what I'd like you to do. I'd like you to add a new script. I'd like you to add a new script to your camera, your main camera. Call it camera follows. Now let me just drag it over here. I've already made it, like I've said. I've already made it. So let me just drag it over here so you can see it. It's a really, really simple script. There's like 4 lines of code in the whole thing. So let's take a look at exactly what the camera follow script does. First of all, we need a target, and the target itself is the thing that we're following. That's the target. We're going to grab the transform of that so we can pull out the transform's position. We will always know where that particular target is. I've made it public so that we can set it up so our camera is automatically associated with the character in the scene. So it's a public thing. We can automatically set it. You could write code if you wanted to find the player in the scene and then add it. That's up to you. I've done it the really quick and dirty way here where I'm just making it public. I'm going to add it in here and make it work. Below that, we've got ourselves a public float value that I've called smoothing. Smoothing is going to be how much ease in and ease out we have in our camera. This value I have here by default of 5, it's a random number. You're going to play with your values and you're going to figure out exactly how much or how little smoothing you want associated with your particular camera. Below that, we've got a vector 3. Now it's a vector 3, first of all, even though we're working 2D space, I've got it set up as a vector 3. This camera follow script can be used in any 3D or any 2D game you want. Part of the reason why it's able to do that is because I have it set up, first of all, as a vector 3, and because of this parameter right here. In our top-down shooter, we're going to have the camera located above our character, where it's going to be kind of almost on top of our character, like right above, like in line with the character. However, if you were building yourself a different type of game, let's say you were building a platformer or something else, you might require an offset of the camera. You want the camera to be a little bit ahead of your character. You want the camera to be, offset in some way. You don't want to pass a particular point, etc. You might have these reasons why you don't want the camera to be particularly aligned, exactly aligned with your player. I have created this offset variable to make sure that you can do that. Okay, so let's take a look at the code now. Down here, we have our start function, and inside of the start function, the offset is set to a particular value. The offset vector 3 down over here, is set to the difference between the transformed position of the camera. So transformed position, this is going to be on the camera. So it's going to take a look at the camera's transformed position, and it's going to subtract from that the target's position. That's going to give us a relative vector difference between those two positions. I want to try and maintain that distance all the time. So the camera is going to be constantly moving to a position that is offset from our character if the camera starts off as offset. In the start value, we set that up. So wherever your camera is to begin with is the offset that it's going to use from then on. Okay, the only other thing we have in here is a fixed update function. I've used fixed update for a very particular reason. You could put this in your update if you want to and do the calculations every frame. However, I have found that putting it in update causes some jitter to occur within the camera, and we want to avoid that. So instead of updating every single frame, we are updating after the physics movement, after our characters have moved, because remember our character is moving with physics as well. So after the character is moved, or at least at that point when the character is moved, that's when we do our calculation on where the camera should be located. So let's take a look at exactly what we're doing. First of all, in the fixed update, I've got myself a new vector 3 called target cam position. Target cam pose, or target cam pause, or whatever, is the position that the camera is attempting to get to. It is looking at the current target, so the actual thing we're following. It's looking at its current position, and it's adding that offset, so we know where we're trying to get to according to where the actual target is. Below that, we are using the camera's transform position. So we are actually moving the camera with its transform. So we're ignoring physics. We're just doing it with transform. We're just kind of moving it quickly along. The transform position, and we're setting it equal to a vector3.lerp. And if you've never used a lerp before, a lerp is really, really simple. There are a bunch of different kinds of lerps as well. And all of those lerps work exactly the same way. Basically, what a lerp does is it takes one value and it attempts to move those two values together. That's what it does. There are several different types of lerps, like I've said. In this particular case, we're using a vector 3 lerp, but there's a color lerp, which means you're trying to make one color move towards another color. There is a float lerp. There's like any kind of lerp you could think of. There is a lerp that does this, takes one value and moves it towards the other. Let's take a look at what we're using here. In our case, we have our transform position, so where the camera is currently located. And we have our position we are trying to get to. So I'm moving its current position to the position it's trying to get to. And then lastly, the third of the parameters here is the smoothing value. So how quickly is it going? And the way a lerp works is it moves very quickly at first. So it makes these big jumps in an attempt to get to where it's going. And then as it gets closer to its target value, it slows down, slows down, slows down, slows down. So let's take a look at exactly what we've done here. We've taken this lerp, and we've fed whatever's coming out of it as it moves closer, we've fed that value back into the transform position. So this value right here, the transform position of the camera, continuously updates. And as it continuously updates, we are moving closer and closer to our target cam position. However, this is being called in our fixed update. So as our actual target moves, the target cam position is also being updated. So these two values are in constant flux, with the transform position attempting to reach its target cam position. If the character stops moving, eventually the transform position of the camera will reach its target goal. That's how this works. It's really, really simplistic. The smoothing value right here will determine how quickly or how slowly the camera itself slows down over time. Okay, so let me move this out of the way. And let me grab the camera follow script, and I'm just going to grab it and add it directly to my camera. Okay, so now it's attached to my camera. If I go to my camera right now and I scroll down, we can see that I've got no target. I'm going to aim that target at the player base. So I'm going to drag and drop this in there. Now that camera is going to follow along, attempt to keep up with that actual player. Let me do this really quickly. Let me go to our basic sprites. Let me just add a couple things around here so that you can actually see the fact that this is working. Okay, I'm going to hit play. So we've got our reference there. And now as I move around, you can see over in this area, over here, you can see that my camera is catching up and There we go. See how it kind of catches up? It slows into its final position. That is far more cinematic, far more attractive than if you are having it simply follow along with the actual object. And that's it. That's how easy it is to make our camera follow. It is about 5 lines of code. Guys, you can use that script in anything that you ever want to. It doesn't matter what kind of game, this camera script will work. All right, guys, I hope you enjoyed it. That's the end of this particular video. We are moving along really well. We've got our camera working. We've got our player working. I think the next video will add some art. I haven't decided what the art is yet, but we'll add some art just simply to explore really simplistic animation. All right, everyone, I hope you enjoyed it. If you did, let me know down below in the comments. Tell me about what you're doing. I always love to hear from you guys. Thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.